Assalamualaikum dear students. This is our lecture 2 in statistics. Chapter is 4 and the topic is probability. And our first section in this chapter is probability basics. This is the formula for calculating the probability of any event. In the numerator we have number of ways in which the event can occur, and in the denominator we have total number of possible outcomes. When we calculate this fraction, we'll get the probability of an event, which will be between 0 to 1. This figure here shows the possible number of outcomes you can have when you roll a pair of dice. Like you can get 1 1 or 1 2 or 2 2 or 6 5 or 6 6 and so on. This figure here shows that as you increase the number of tosses, the proportion of getting heads moves closer and closer to zero point 0.5. There are three basic properties of probabilities. As I said earlier, the probability of an event is always between 0 and 1. And the probability of an event that cannot occur is 0. And we call that kind of event as an impossible event. And the probability of an event that must occur or a certain event is always 1. Now let's discuss what are events. But first, we need to know what is sample space. The sample space is the collection of all possible outcomes of an experiment. And the event is collection of outcomes for the experiment. That is any subset of the sample space. The Venn diagram here shows that here E is an event and everything outside the E is not E. In figure B, we have two events A and B. The intersection of these two events is another event which is A and B. And if we combine both A and B, then we'll get another event which we call A or B. And not E means the event that E does not occur. A and B is an event which means both A and B occur. A or B is an event which means either A or B or both occur. So what are mutually exclusive events? Two or more events are mutually exclusive if no of them have outcomes in common. Some rules of probability. A special addition rule is what? If A and B are mutually exclusive, then probability of A or B is equal to probability of A plus probability of B. Complementation rule is what? Probability of E is equal to 1 minus probability of not E. Then we have general addition rule that probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Now let's move on to conditional probability. Conditional probability is the probability that event B occurs given that event A occurs is called conditional probability, and it is denoted by P, probability of B given A. which we read as the probability of B given A. And in this, probability of A should be greater than 0. Multiplication rule states what that probability of A and B is equal to probability of A multiplied by probability of B given A. After studying probability, a famous distribution that we study is normal distribution. Normal distribution is constructed when we make a normally distributed variable, which we discussed in our lecture 1, that we standardize any variable using this formula: x minus mu, which is the mean, divided by sigma, which is standard deviation. Then we get a standard normal variable that follows a normal distribution, standard normal distribution. There are four basic probabilities of standard normal curve. Number one is the total area under the standard normal curve is 1. Number two, the standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis. The standard normal curve is symmetric about 0. That is, the part of the curve to the left of the dashed line is the mirror image of the part of the curve to the right of it. Number four is almost all the area under the standard normal curve lies between -3 and 3. Empirical rule for variable suggests that for any normal distribution, approximately 68% of all possible observations lie within one standard deviation to either side of the mean, and approximately 95% of all possible observations lie within two standard deviation, and 99.7% of all possible observations lie within three standard deviation to either side of the mean. To check whether a certain distribution follows a normal distribution, we use normal probability plot. If the normal probability plot is roughly linear, we can assume that the variable is approximately normal. Uh, this table shows the normal scores for different values of the distribution. When we plot these normal scores, we can get the idea that if it is roughly linear, then the distribution we have follows the normal distribution.